Okay, so we are ready to get started with part 4 notes. And I am going to introduce to you what a system of equations is today. Everything that we did, all those warm-ups to get to this part 4 have to do with a system of equations. And we couldn't do this until you knew all those. So first of all, let's talk about what a system of equations even is. A system of equations is when two or more equations share variables. When two or more equations share variables. And the variables that we're going to be talking about that are shared are the x and y variables, okay? And so that's basically like if I were to say y is equal to 3x minus 1 and y is equal to 2x plus 7, that is a system of equations because there are two or more equations and they share x and y. Sometimes you'll see it written with a little bracket on it like that, okay? So the definition of a solution for a system, because we used to just solve equations. Like I used to just give you one equation and you would solve it. The solution for a system of equations is going to be an ordered pair, meaning an x comma y, that is a solution for both equations in the system. An easier way to remember that is it's where two lines would meet if you graph them. It's where two individual lines, if I graphed each of these, that's where we're gonna say intersect. That's the math word. When graphed, okay? And good thing we just reviewed how to graph a line. So right here, you just have a picture of what a system of equations looks like, okay? This blue line is y equals negative x plus 5. This red line is y equals 1/2 x plus 2. And this green point is the solution to that system because it's the point of intersection. And remember, we label it 2 because this is our horizontal movement, comma 3. And so that is the solution to the system of equations. And so now this whole lesson, part 4 and part 5 notes is going to be talking about how we find those solutions. But before we do that, I want to prove to you, okay, mathematically, I took this blue line and made it right here. I took this red line and made it right here. So let's do this. We'll do this is the red line. This is the blue line, and we're gonna prove to you using algebra, not a graph paper, because you don't always have graph paper, right? And I'm going to ask you to remember that if I asked you to take this x value of 2 and this y value of 3, and if I plugged the 3 in here, because that's y, and the 2 in here, do you think they would equal each other? Okay, well, let's find out. So if y is 3, does that equal the opposite of x, which in this case is 2, plus 5. So really this is negative 2 plus 5. And if you remember your integer rules, this does equal 3. That is a check, which means yes, this is a solution to this system, meaning it is on this line. And I know it is because we just graphed it. So then I want to do this one. I want to do the same thing. I want to take this y value, which is 3. I want to take half of the x this time, add 2 to it, and see if I get the y. So if x is 2, half of 2 is 1. 1 plus 2 also equals 3. We shouldn't be surprised here because we just visually saw on the graph paper that the point 2 comma 3 is the point of intersection. And now because I have two checks, a check means yes, yes, it's on the line, and I can guarantee then that it is the point of intersection, okay? Because there are times where it might check for one but not the other. Like let's say I had a point right here. This point, -1, +2, would check for the red line if I plugged it in, but it wouldn't check for the blue. And if you get a yes and a no down here, then no, it's not the solution to the system. So I could give you a bunch of graphs all day long. And now that you know what the solution to the actual system is, all you have to be able to do is read an ordered pair. That's the point of intersection. From the origin, I'm going 2 to the left. So I went 2 to the left. That's my horizontal movement. And I went 2 up. So the answer to this, the solution to this system is 2, -2, 2. The solution to this system, I have a horizontal line here. I go 2, 4, be careful, look at your your axis is what they're labeled. You didn't go 2, 1. I went over 4 and up 2. So I went over 4 and up 2. That is your solution to that system. And then this last one right here took me 2 to the left, but 1 down versus what we did over here. So I went 2 to the left, but 1 down, and that is as simple as that gets, okay? So that is identifying the solution to the system, but you know what? That's when the lines are already graphed. It's not gonna be that easy, right? So today, I want you to notice, I'm gonna give you an ordered pair, and I'm gonna give you a system, and I'm gonna ask you to not use the graph right away. I want you to use algebra first to see if I were to graph these two lines, would they, in fact, intersect at +1, -1? That's what I want to know right now. If I graph these two lines, would they meet right here? But let's say you don't have graph paper at first, so we're going to, let's do this one here. So I'm going to take, if x is 1 and y is -1, I'm going to try to use this. So let's do the y equals -2x + 1 here. I'm going to plug in -1 here and +1 here because that's x, and see if this equals. Does -1 equal -2 + 1? Subtract, take the sign of the larger, and yes, I get a check. So right now, I know if I were to graph the line y equals -2x + 1, I'm going to do this one in red. Remember, a negative slope means go down 2 over 1, and if I were to connect that, I would see that, okay, so far so good. This line includes the point 1, -1, but now I have to see when I go to graph this blue line, if that one actually also includes that. So let's take the y equals 3x - 4. Let's input this y into -1. Let's do 3 times the x, subtract 4, and see if that also equals each other. This, remember, is 3 plus -4, and I have also -1 equaling -1, which means that yes, you can put a big fat yes at the bottom here, that 1, -1 is in fact the solution to the system because, watch here, let's graph it and check. -4. My slope, remember when it's a whole number, you have to give it a run. So this is gonna be a rise of 3, and look, I literally landed right on it. So when I graph these two lines, I can guarantee, I can see with my eyes that it is in fact where they intersect. Because I put 2 checks, I can circle, yes, it is. That is the point of intersection. Let's do another one. Now I want to know if the point 0, 5, which by the way means don't go left or right, but go up 5. I just am curious to see if I were to graph these two, is this the point of intersection? So let's do what we just did. If x is 0 and y is 5, and I do y equals 2 times the x plus the 5, will that balance? And let's say y is 5. Let's do 2 times the x, which is 0. 0 times anything is 0. And 0 plus 5 is 5. So far, so good. Check, meaning I know if I were to graph this line, I know 0, 5, it will go through it. Now let's check to see if the blue line also hits that point. And if it does, then yes, it's the solution. If it does, then it isn't the solution. Okay, so I have 5 equaling -4 times 0 is 0. 0 plus 1 is 1. It's not 5. And so we get not a check mark, but an X, We get an X to show that, no, this is not on this line. So watch, if I were to graph this plus 5 and go up 2 over 1, here's this line. Down. Here's my red line. My blue line has a y-intercept of 1 and a slope of -4, which means I'm going down 4 over 1, which is, if you remember, the same as going up 4 and left 1. It just misses it. So you can see with your eyes, this is the 0.05 that I was wondering about, and it doesn't. It touches somewhere crazy in the middle, like a fraction. So I don't have 2 check marks. It's on this line, but it's not on this line. So is 0.5 a solution to this system? No, it's not. Okay? So I want you to try this next one on your own. Go ahead and pause the video. I know they look a little different, but you're literally still gonna just plug this 3 in here, this 4 in here, do a little bit of multiplying and adding and see if this equals 2, see if this equals 3. You're looking to see if you get 2 checks. So go ahead and pause the video and then unpause it to check it when you're done. Okay, so my first equation, I wanna know if the 0.3, 4 satisfies this system. I know I want to show you, like I said, a couple different ways. This says, if we graph this, would it intersect here? This time I said, is it a solution? This problem I says, does it satisfy? All 3 things mean the same thing. Is it a solution? So let's take this -2x, let's add the y to it and see if it equals 2. What's our x value? 3. Let's add our y value to it and see if we get 2. This is -6 plus 4 equals 2. When I subtract, I get a -2. And does a -2 equal a +2? Does owing somebody $2 equal the same as having $2? No. So I do this, I put an X, and you're gonna love this next part. I'm done. I don't have to do any more. I don't even need to check to see if 3, 4 is on this line, because it doesn't matter if it is. Because in order for me to say, yes, it's where they meet, you have to have a check for both. And if the first one doesn't check, then I don't even care about the second. It might be on it, but it does not matter. As soon as I get 1 check, I can put a big check mark as no, okay? So let's take a look at this. In order for an ordered pair to be yes, the solution to the system, you must get a what kind of statement? This was true, this was false. So they both have to be true. You must get a true statement when you plug the variables into both of the equations. Not just one, it's gotta be true for both of them. So here we saw in example 1, I got 2 check marks, it worked for both, so I circled yes. It worked for the first one, shoot, so I kind of wish we would have done this one first, because if I did this one first, I could have stopped. I could have put a no. And in this last one, we got the no first. Understand?